Well, good morning, everybody, and welcome to the Satellite and NTN Summit. Thank you very much for being with us today. I always like to start off by doing that because we never take support for granted. We know this is a big topic in the industry right now, has been for some time, but it really only continues to grow. And it is genuinely our pleasure to be able to convene all of you here in Barcelona to talk about it. And I think there's going to be a lot to talk about. My name is Tim Hatt. I am going to be running the summit today. I work with GSMA Intelligence. We love covering satellite within the telecom industry, and I think we're going to have a great discussions. I want to thank you all for being here. I want to thank our wonderful sponsors. As you can see up here, Comtech, SES, Intelsat, UK Space Agency, and ESA. We have a great who's who list of speakers for our panel. So I'm going to kick off with a sort of opening presentation around 15 minutes or so. We'll then move to the keynotes, 2 of them. We'll have a panel, and then intersperse with a few other keynotes and panel. I apologize for those of you who are peering in. There are space limits that we're just not allowed to go beyond, but hopefully you've got a good view there. If anybody does get up and leave, you're welcome to take those seats. That's a bit about us. You can visit our website and I've got some QR codes to show a lot of our recent research on this topic, which you can go and download. But for now, I think I put this slide up last year as well because it is an important level set. Why we're all here is really that there is a huge amount of capacity gain in space becoming more crowded. And I see a lot of you are taking pictures. You're welcome to do that, but these slides will be available, and they're in our published work. With the low Earth orbit rise, witnessed the last several years, and that continues to grow, you have this huge projection up. There's cost efficiencies at play, the technology is improved, and most importantly, there's a pragmatic realization that this convergence that we're seeing between the telco sector and the satellite sector makes a lot of sense for both. It's a win-win. And we will talk to the use cases that come to that, but this huge capacity gain really is changing the game for what is possible. Now, our team tracks the actual penetration of the satellite sector across different regions. And the main point from this is that if you look at the number of partnerships that mobile operators have formed, it now represents north of 70% market share. What do I mean by that? That means that operators representing 70% of the mobile subscribers worldwide have at least one, but often more than one, satellite partnerships. Okay? And this isn't like some of the stuff that has been around for 20 or 30 years, maritime partnerships or home broadband. That is including the mobile side. That's direct to device, it's other services, but all bundled in. And that's growing at about 20 percentage points a year. Very much a global phenomenon, not just regional. So there's a momentum here. We're seeing that across the board. Now, this is a bit of a different way, kind of an easier way, arguably, to view that. And this map is changing by the week, but what this shows is the geographic distribution of where those partnerships are, and the footprint of the mobile subscribers of those operators. So when you look at it, there's sort of 2 points to make. One, it's almost everywhere. And 2, you actually have a transition now in 2025 where we're moving from pilots to commercial launches. Now, that doesn't mean that satellites will be 24/7 continuous service availability this year, but really, we expect that over a phased 2 to 3 year period. And so as we do, this map is going to get more to the red and the kind of turquoise colors, and you're going to see that kind of blanketing around. We'll speak to the use cases on consumer side, on the IoT and business side, and in the disaster recovery area, but this is, again, a view of how things are changing. Another way of showing that, this is a tree chart to show some of the partnerships that some of the larger mobile operators have. This isn't exhaustive, so there are things not shown, but you can see here the point of this is really to show the scale of the subscriber base that the satellite can be sold into. You look at Geo, you look at China Telecom, we look in Europe here with various groups, Vodafone, of course, in the US, Verizon and AT&T, T-Mobile, all involved, Starlink, AST, and others, where this is now something that is being adopted to a very large scale. Now, anybody here who is paying attention to satellite, you'd have to be living in a cave to realize that direct-to-cell is not, is one of the big things happening right now. It's what's garnered a lot of momentum, and I think it speaks to the, standardization of NTN in the 3GPP standards in Release 17 that has really laid the groundwork for being able to deliver services direct to people's phones. That's a game changer because it takes away the dish that was previously required for the hop, makes it easier for people to connect, makes it cheaper, and therefore is ultimately more accessible. Now, again, this data is changing all the time. This is a selection of tracking data that we cover around the partnerships that some of the major satellite companies have formed. And don't get too bogged down in the individual data points. Suffice to say, though, that for a lot of these, Starlink, AST, Link, and increasingly others that we'll hear from today, either have a significant number of direct-to-cell services in the pipeline or are planning to launch. It's obviously not the only dimension, but this has implications for the consumer side, for extending coverage to those who don't have it, for roaming, and on the business side for IoT devices. We've got some charts on that, but this just shows you the extent of that direct-to-cell move. Now, on the consumer side, you see that a lot of this is sort of anchored in the coverage needs that people have. This is from a survey we ran last year across, I think it was 10 countries, where we asked people, and this is just one cut of it, we've published some work, when we asked people what their current network coverage from their land mobile operator is, and how much they would value coverage to be ubiquitous. Again, you get a sense of the countries here, but there's remarkable continuity that on the go, around 2/3 of people really want that at a high quality. And in some cases, there are still gaps, despite terrestrial coverage having reached, over 90% of population, and for mobile broadband, even higher than that in some regions. So you get to this point, there is a clear consumer demand for it. Now, one thing we didn't really get into last year, though, that we're going to get into in the panels here today, is what does this ultimately mean in terms of whether people will pay? Obviously, the decision about how to price is a commercial decision for individual companies, but it's still nevertheless important to understand whether there is an appetite for people to pay. And this data here is from that survey, and essentially what it shows, if you ask people, okay, you tell us you're interested in having satellite service, will you pay more than what you currently do? 60% of people say they would. If you add up all those turquoise bars, that's what you get to. And within that, the average is about 8 or 9%. In other words, if you're paying $20 a month, you'd be looking at sort of a $2 ARPU rise. Again, how that is priced will depend on the individual circumstances. Some operators won't price it at a premium at all, but some will. And what this shows is that there is a willingness to pay for ubiquitous coverage at a good level. Right, switching gears to the IoT side, this is a kind of a pie graph to show what we see as the addressable sell-in base for satellite into the IoT sector. And again, we don't have time to get into the individual sectors, but there's sort of 2 points. One, if you look at IoT overall, we think that'll get to sort of in the high 30 billions of devices by the end of the decade that are connected. We think satellite can address at least 2.5, probably north of that now, probably more like 3. So there's significant sell-in, But more importantly, it's across a range of industries. As much as automotive and telematics might be the largest in terms of volume, we're seeing in precision agriculture, utilities, manufacturing, and others. A lot in the last 12 months has happened in terms of satellite being sold into IoT, and I'll come on to it with the device world doing what it is, there's a lot more possibility. The standard setters never stop, and so as we move into the next wave, this is a kind of subway chart just to show what functionality gains we get with release 17 and then release 18. What we had already is sort of the maiden satellite service, but if you look in that middle donut moving out to the right, we're going to see gains in, for IoT through RedCap compatibility. We got new spectrum bands, integration for drones and UAVs, another part of the NTN conversation. And so the technological gains that are possible through this, continue to grow at the standards. We should start to see more taking advantage of this this year. So what does that all add up to in terms of like an addressable revenue base? We think that when you sort of add up the consumer side, the B2B, and the government, you get to kind of a $30 or so billion a year addressable revenue opportunity for the telco operators in satellite by 2035. About 2/3 of that, roughly, is consumer, sort of 30% business and the rest government and defense. And I think one of the interesting things, though, is that it will be to see how this plays out. Again, this isn't a firm forecast, but as we start to see the constellations be deployed and services implemented live, and we get data from the operators and others, we'll get a sense of how realistic that is. But really, when you look at that, that's a 2% uplift on the overall sector revenues. So there's a clear reason as to why so many operators are interested in this. We'll talk about spectrum models. We'll talk about what that means for policy and regulation. These are, we don't need to get too into detail here, but I think the importance is to understand there are different ways of delivering satellite services on different spectrum bands. It's very important to understand the technical side of that and understand the trade-offs. I think it's being done differently depending on where you are, but we'll have a discussion about what that means for go-to-market strategies and service integrity. Right, so the last slide then is sort of what are these big questions? What does this all add up to? And in many ways, these are the questions that are going to form the basis for the panel chats today, and I hope will be covered by some of our speakers. There's technology questions, there's business model, / commercial questions, there's regulatory questions. Is direct-to-device real? Is it the real deal? Will that continue? How do we get service speeds up and latencies continuing to come down? The commercial model, does this primarily stay a wholesale model? Do some satellite companies try to go direct to the customer? We know that Starlink has done that with broadband. Will others try it in mobile? Haven't seen much of it yet, but open question. And on the regulatory side, I talked about the standards. ESA is here today. They're doing a great job at leading the sort of standardization with the 3GPP NTN for 5G and eventually 6G. We'll be interested to hear from them and others how that plays out. And ultimately, adding up into a question of how this technology matures and how it's monetized. So I promised you that I would put up some QR codes of our research so you don't have to take tons and tons of pictures. I'll give you a sec to just flash the QR codes up here. These are at our website. Have a look. Any questions you want, you can direct them to me after the summit. Just give a couple more minutes before we get on to our first speaker. And hopefully that has given a good primer into the discussion, and we will move from there. So thank you guys very much, and I am going to move to our first speaker, which is Daniel Gazinski from Comtech. Daniel. go.
Thanks, Tim. That was really interesting. It's always exciting, when you kind of take a step back and think about the level of transformation that we've seen within the satellite industry at large and the transition towards NTN. It's kind of an interesting thing. I find that, certainly at this show last year and then this year, there's a significantly increased emphasis on, the number of people that understand NTN, that are viewing it as a priority, making meaningful investments, and you're starting to see as you walk around the floor a number of cases where it's a prime discussion point amongst many of the folks here. What's been really interesting to me is I found over most of my career in satellite, very few people that you'd run into in casual conversations even understood how critical satellite communications were to modern infrastructure. And I think today, any conversation you have with an acquaintance, a family friend, colleagues outside of the industry, everybody understands satellite as a result of the innovations that have been launched. And whether it's partnerships from AST, whether it's the work that Starlink's done, it's been brought to front of mind, I think, across the world at large. And it's really, I think, a meaningful point to take a moment and pause and realize just how critical satellite and NTN infrastructure is going to be to our future transition. It's hard to understate how important NTN is to the future of the satellite industry and to the future of the mobile industry. It's provided us an opportunity to really sit back, rethink our architectures, think about differently how we approach the market, customers, partnerships, and bring to bear a new set of solutions that meaningfully offers something new and something better for the overall customer experience. So I'll launch in a little bit with kind of a quick background on who Comtech is. So I run our satellite and space business, which has been around for about 60 years, not long after the launch of the very first commercial satellite. We have deep roots in the satellite industry. We have products operating in over 200 countries and on orbit on all 7 continents. One of the core areas of our business is supporting mobile network operators with cellular backhaul. We estimate that about 70% of MNOs that rely on satellite backhaul have Comtech equipment somewhere in their ecosystem. We also have deep roots on the terrestrial side. We have a business dedicated to terrestrial and wireless communications. We provide next generation core services, so emergency call handling, call routing, as well as value add services, so SMS messaging, precision location-based services, wireless emergency alerts, or cell broadcast, places where we've already seen the benefits of transitioning to cloud-based services, as well as some of the pitfalls and challenges associated with making that transition. Quite a bit of attention will be paid today about the distant future state, right? The things that are built if you're developing from a clean sheet and you don't have existing infrastructure that you have to work within, and you have the opportunity to fully modernize. And it is helpful to look at the distant future and work backwards from there, so we'll do a little bit of that. But I also want to emphasize a bit where the rubber meets the road, right? How do you practically implement things today? And one of the unique challenges for satellite in general is the durability and the length that we expect to have infrastructure out in the field. I've told stories before. I've been out and I've seen Comtech modems that have been operating since prior to when I was born, that are still being pressed into service many years later, with the goal of maximizing the return on invested capital. And satellite is an incredibly capital-intensive business, and any opportunity that's there to continue to use infrastructure provides a meaningful benefit for those operators, where they're still able to support legacy customers that haven't modernized, and they don't have to make the same level of investment that would otherwise be required. So I'll jump forward a few slides, and I'll pop up what should be a very familiar NTN architecture. And what I have shown up here are 2 different configurations. The upper configuration is what's referred to in the 3GPP architecture as a transparent payload, what most people that have been in the satellite industry for a long time would just call a transponded payload, where what comes up from the user equipment goes back down to the hub and is processed there. And there's an approach that allows you to support a 5G architecture around this. And then in the lower graphic there shows something operating on a more modern architecture, something that in the satellite industry would have been called a processed payload, referred to through GPP as a regenerative payload. And a couple of different architectures that are possible there. Most of the folks that we're working with today that are launching new constellations and doing clean sheet architectures around a 5G NTN type standard are launching satellites under that approach. One of the challenges is there's a number of satellite operators that have hundreds of millions or billions of dollars worth of assets that are currently on orbit that really fall under that upper architecture. And one of the unique challenges is, and kind of the curse of the incumbent, is you have to continue to support those existing customers along the way towards modernization. And so bringing up 5G NTN services alongside those legacy capabilities, continuing to support customers that may have a 15 or 20 year upgrade cycle to bring themselves forward into the next generation architecture. So a flashback here to kind of where the rubber meets the road. This shows what a typical satellite operator's teleport or hub architecture might look like today. And if you look at, I guess over on the right-hand side, there's a couple of different paths that they might be on their path to modernization. Up at the top is an analog intermediate frequency, L-band type architecture. The vast majority of bits that go over satellite today are likely in an analog intermediate frequency architecture. In the middle, we have digital intermediate frequency, and there's been some great work over the last couple of years through the Diffie consortium, moving towards this digital intermediate frequency architecture that allows for really connecting any antenna to any processing architecture. And then what that's allowed for is a transition, and we're seeing just a very few folks starting to move towards this fully virtualized architecture shown at the bottom. The vast majority of our customers today are somewhere in between the analog IF and the digital IF, and they're working through that iteration. And I'll say, for one of our very largest customers that's on that path, they've shared with us it's a 15 to 20 year transition period for them to fully modernize their architecture from L-band to digital IF. And I think that kind of provides a reasonable expectation for the capital outlay that most folks are prepared to put forward and a reasonable transition time. And so one of the things that we've thought about pretty intensely is how do we make sure that a 10, 15, 20 year transition period is supportable and workable for customers that need to have those capabilities operate simultaneously. And you'll kind of see some of the cleverness that's been done on this architecture. We've got deployed as part of this Diffie modernization effort platforms that support both analog IF and digital IF simultaneously. We expect those things to coexist in the ecosystem for a very long period of time. That digital IF does provide a really meaningful total cost of ownership advantage to operators. There's tremendous opportunity to reduce cost associated with analog IF switching. And it also supports a transition towards what we refer to as an ultra-wideband downlink. And that's a really interesting benefit that's provided by the ability to support wide instantaneous bandwidth simultaneously. It was developed initially primarily for defense communication applications, so spread spectrum applications, but it's also translated very well to most of the modern 5G NTN architectures where the downlink from the regenerative satellite tends to be a very wide bandwidth, very high throughput, 5+ gigabit per second link that needs to have that 1 gigahertz of instantaneous bandwidth to support the data rates coming down from the satellite. Flip back to this architecture, show a couple of things here that I think are noteworthy, right? And so in the first case, if you're a traditional operator that's somewhere along that modernization path, you've got some of the digital architecture that's there, you actually have the ability to support on a transparent payload satellite, FR2 5G signals on a transponded payload, bring that down, digitize it, and then support within fairly standard architectures all of the 5G NTN standards. And there's certainly challenges relative to link budget performance and some of the other considerations on what you can get through that sort of payload. But it allows for the continued operation of both legacy systems simultaneously with 5G NTN waveforms. We firmly believe that that transition period for user terminals to be fully upgraded in the field, particularly for satellite ecosystems that are by definition dual use. The vast majority of commercial satellite systems both have to support government users as well as commercial use often simultaneously. And so the ability to support government users that have very long, very slow upgrade cycles alongside commercial users simultaneously is afforded by this approach to the architecture. And then ultimately, leveraging the same ground hardware, once regenerative payload satellites are launched and operational, the same ground architecture continues to support those very high throughput, very high bandwidth, what's effectively a feeder link. And those can be, traditional legacy satellite waveforms, so things like DVB-S2X, or OFDM waveforms, which are going to be selected from primarily based on link budget performance. And in very high SNR applications, OFDM with good digital pre-distortion and linearization can outperform S2X, but in lower SNR applications, we're typically seeing S2X tends to outperform. The beauty of this common architecture approach, right, is it allows for the coexistence of that legacy approach. So whether it's government terminals running standards like DVB-S2X or NATO standards simultaneously with 5G NTN that's decided at the processing unit rather than at a unique piece of hardware. I'll flash this up real quick. Part of what we've shared in the past and are working on a modernization effort now for the US DoD that is going to support several international governments is a broadly digitized approach. What I found interesting about this slide is the architecture that's being built for this sovereign gateway architecture is functionally identical to what would be delivered to support a 5G NTN architecture. And as mentioned before, in a world where satellite operators always have to think about the dual use application of those satellite systems, the ability to support both of those simultaneously provides a meaningful benefit. I'll leave here and hand back to Tim in just a second. I think two major points that I think are really interesting as I look at it. We're at a point where the rubber is starting to hit the road. We're starting to see meaningful investments in the deployment of 5G NTN. I've always said that you can tell an industry is maturing when people spend less time thinking about what could be and more time talking about how to practically solve the hard problems. The more emphasis that's put on total cost of ownership, real cost associated with an upgrade, the closer you are to seeing systems broadly deployed. I think ultimately, realistically deploying the investments that have been made in previous years in satellites that are on orbit or on order and so far along track that they have to be launched it is critical, right? And continuing to support those legacy existing customers while maximizing those satellites that are on orbit is meaningfully valuable. Regulatory is one of the really interesting wildcards, and it's flashed up before. I think ultimately preserving optionality throughout an indeterminate regulatory set of decisions is really important. Whether you're reusing terrestrial bands or MSS, most of what's speculated about the future of NTN presumes a regulatory outcome that hasn't happened yet. And I think preserving maximal optionality in ground systems investments is the smart play for a satellite operator today. Appreciate the time. Tim, I'll hand it back to you.
Daniel, thanks very much. Great opening presentation. Lots to think about. All right, we are going to move on to our second keynote speaker, which is Nadine Allen, who is the head of enterprise and cloud from SES. So please welcome Nadine to the stage. There you go.
Which one? Green?
This
Yeah.
forward green.
Great.
Thank you.
Good morning. Satellite has never been more relevant as a reliable option to achieve high performance, ubiquitous global connectivity. And the industry and the landscape has evolved rapidly in the last few years and is expected to continue at the same pace for the foreseeable future. In this presentation, I talk about what has happened in the industry over the last few years and what brings us to where we are today and where we are heading next. Satellite has been a significant contributor to media distribution for many years. And SES has been and continues to be at the forefront of media innovation, working with major names in sports and events industries. Media distribution for companies such as the National Football League, the major tournaments of the Association of Tennis, and the world's most watched football and motorsports. But the shift from satellite to broadcast, for satellite to data, has been truly groundbreaking. About a decade ago, in 2014, SES pioneered the introduction of NGSO satellites with its MEO solutions. And with it brought software-defined technology which has delivered unprecedented flexibility within the industry. With the advent of multi-orbit solutions incorporating LEO, we've also seen further significant dynamic shifts within the industry. And with these capabilities and the significant demand for data and cloud services, we are moving from what has been a relatively static broadcast model to a dynamic data-centric model. So what is it that truly drives all of this forward? Between 2019 and 2023, we saw 700 million new internet users. In 2024, there were just under 300,000 satellite-connected Wi-Fi hotspots. But 32% of the global population still live in areas of underserved internet access. And there are concerted efforts to fill this gap. But we also see that enterprises are seeking to drive global digital transformation, which requires them to have high-performance primary and secondary connectivity in hard-to-reach places in order to complete their global footprint. So in order to meet with these needs, we have developed a multi-orbit combination. So let me explain how this works. Our multi-orbit combination offers the best fit architecture based on customer needs across various industries. And we work with a lot of diverse industries, including energy, mining, cruise, telecom, and government. Often, when you work with one orbit, there are normally some performance trade-offs. But multi-orbit has become a viable option to get much closer to giving customers exactly what they need. In this scenario, the scenario of a major multinational sports championship, we can use GEO to give us robust broadcast capability. We can use MEO to deliver mission-critical communication resilience for the crew and for the event itself. And we can use LEO to support spectator Wi-Fi. In industries like energy and mining, MEO is used to deliver critical outcomes in productivity, safety, and sustainability, whereas LEO, for example, would probably give more general connectivity performance as well as meeting the needs of crew welfare. And network intelligence in both ground-based hardware and software-defined satellites is essentially allowing us to orchestrate the data flow across these three orbits in a way that is meeting the needs, the diverse needs of these industries. As the pioneers of MEO technology, I want to just take a moment to explain some of the special properties of MEO satellites and what makes them an integral piece of this multi-orbit combination. O3b mPOWER is our second-generation MEO constellation. It delivers a strategic balance of the highest throughput available from satellites with reliable services, intelligent flexibility, and predictable low latency. In fact, we have yet, in all of our tests with the industries that I mentioned, we've yet to find a use case or application we cannot support with latency from MEO. Medium Earth orbit actually grants us some specific advantages. By being much closer to Earth than GEO in a circular equatorial orbit, we can provide extremely steady, low latency communication paths. MEO is designed to provide highly configurable beams, delivering multiple gigabits per second of throughput from each link with symmetrical high upload connections. Very important for enterprises who are trying to return traffic from remote locations back to central cloud sites. As a company who's also committed to improving outcomes and sustainability, we can cover 80% of the planet with just 6 satellites. So we're already working with some pretty data-hungry industries. I've already talked about energy and mining as being 2 industries that we are working extensively with, but there are others. 5G scale mobile backhaul, comms on the pause for governments and telcos requiring portable but high-performance connectivity, aero services for commercial, private, and military flights, telco services, including cloud-scale enterprise and international trunking. And lastly, our first triple orbit solution was delivered for the always moving cruise industry. But our story doesn't end here. So what's next? We see continued significant transformation driven by massive data growth, but also the need for real-time decision-making. The number of broadband users connected by satellite directly or indirectly is set to increase from 94 million in 2024 to 153 million by 2031. 165 countries have already adopted national broadband plans, highlighting the significance or the relevance of satellite for digital inclusion and disaster recovery. SES is already working and has been for quite a few years now on supporting digital inclusion across the globe, with initiatives such as the Internet para Todos program in Mexico, and also in Brazil, where we are working in partnership with Telebras to connect communities and schools using geotechnology. Orange, for example, have exponentially increased internet both domestically and internationally in Central African Republic. So what do we need to do going forward in order to meet with all of this increased demand? Well, first, we are shoring up our foundations in GEO. We are adding further software-defined satellites, and we are investigating the use of micro-GEO and life extension vehicles to proof our future. We are also, of course, tracking the direct-to-device emerging opportunity, and it's not just about D2D capabilities there, but also the need for resilience and coverage enhancement. And finally, we have been awarded a leadership role in the SpaceRISE consortium, which is the consortium that is designing, delivering, and operating the EU's future multi-orbit satellite system, known as IRIS². IRIS² will deliver ultra-high-performance connectivity, neutral connectivity, utilizing MEO and LEO, and it will cover the planet. And other relevant technologies that I think you've already heard about, of course, we see a promising extension of satellite technology in direct-to-device. The opportunity here is to provide services where there is not reliable cellular coverage. We expect to see 130 million subscribers and $6.8 billion in annual service revenue by 2032, and common use cases will be emergency services, remote messaging, and IoT. And in IoT, powered by satellite communication, we see significant growth potential there too, with 16.3 million devices expected by 2032 in areas like smart agriculture, mobility, and energy monitoring. And a subsegment in mobility will be connected cars, and the need for cars to stay connected when they're on the borders of terrestrial networks. As somebody who has come from the telecoms industry into the satellite industry, I'm actually really excited about the potential to drive both convergence but also further innovation in satellite. And these are some of the things that we are working on in order to drive space-based intelligence in future services, both at a satellite level but also on the ground. The first is that we are further extending our virtualization of ground infrastructure. This is enabling multiple use cases and multiple industries to utilize the same platform. The second, and a really significant area for us, is the use of artificial intelligence. So going forward, we will be using AI to analyze our network, to understand trends within our network, and to give us insights that will help us to better predict future capacity and coverage. We have also fairly recently entered into a strategic partnership with QEVA, who were formerly Neuron, who are working with us on our next generation multi-orbit solutions. And we are leveraging their AI and machine learning technology in order for them to look at our network real time and the traffic real time in the network and make sure that each application follows the best route and the best orbit, meaning that we give a consistent quality of experience to customers, even in changing conditions. The third area that is exciting is what we call inter-satellite relays, where we utilize MEO and GEO for lower orbit satellites, particularly things like Earth-based observation and scientific satellites that can stay connected to Earth, even over oceans and in areas where they don't have access to ground station. And the fourth area, but certainly by no means the last, is that we're seeing a considerable increase in the need for us to support sovereign networks, both for governments and also for enterprises who really want to ensure that their encrypted data passes silently through our satellites without ever touching our ground network, because there are, of course, potential significant security benefits from that approach. So, as we look to the future, significant commitment to innovation, exceptional customer experience, and sustainability, all of those things from SES are designed to ensure that satellite increases its relevance as a way to achieve highly reliable, ubiquitous global connectivity. I spoke earlier about our multi-orbit solution, utilizing all three orbits, and you can see that here at MWC on our stand. So we'd love for you to drop by and visit our booth. Thank you.
Nadine, thank you very much. Okay, it is time in the program that we are going to bring up our first panel. Hopefully we've given some good food for thought so far, and the presentations as well. But we want to get into some more detail on this. So super pleased to welcome all these great people. So if they could come up, Scott Wisniewski from AST Space Mobile, Anirban Chakraborty from Comtech, Freddie Sodergren from Ericsson, Amina Bubendir from Airbus, take a seat please, and Rika Nakazawa from NTT. Do you want to spend a second? If you go in the second chair, I'll sit here. So, yeah. Please. All right. Guys, thank you very much for joining me up here and for being here today. We got 35 minutes for this panel, and there's lots to get through, but I think I started off the panel last year talking about why is satellite important in the connectivity conversation now. I'm not going to ask that anymore because I think that's self-evident. But I do want to reflect on what's changed in the last 12 months and give you each a chance to sort of weigh in on that. And maybe, Scott, I could start with you. What do you think what are the key changes we've seen in the last 12 months that's really accelerating the momentum we're seeing?
I think it's the the near-term availability of in-orbit architecture that supports the ecosystem. So, this industry is being created from zero.
Yep.
4 years ago, it was called cold fusion and impossible, but us and others are starting to put in-orbit architecture in place that can facilitate new applications. And ultimately, the key unlock for us is that space now has the ability to address the mass consumer market. And that's really the unlock that I think that's got a lot of excitement here.
Yep.
Is because space is no longer just about enterprise or government. It's now something that can be available to everybody. It's being democratized. It's going directly to the 5 billion phones in people's pockets today.
Yep.
And that's a big deal. And I think as we get closer and closer to real consumer plans that can be used by all of us, not just those with a security clearance,
Yep.
I think that's a big deal.
Anirban?
Yeah, so I'll say, Tim, I'll borrow one of the things from your slides, which was very interesting in terms of the partnerships that we saw, right? I mean, between the terrestrial providers and the satellite operators. But interestingly, I've also been tracking that in the last, let's say, 12 months since we last met here, how has the ecosystem evolved, right? I mean, we have a huge dependency on the chipset vendors. Not to mention, the handset manufacturers or even satellite operators, but collectively, how many patents have been filed on the 3GPP release 18 and going forward in release 19? That's remarkably more than 400. So to me, that's a very exciting news. It's a refreshment because people are not just believing in it, they now want to be a part of it. They want to contribute to it. They want to make it successful and get into it. So I think since the last 12 months since we met, this thing has, I would say, caught on fire.
Yeah.
Yeah.
Amina?
I would say as a community, we are raising the awareness about the need for global connectivity. And the two keynotes before helped a lot introducing, so we don't have to repeat this. But by definition, satellite communications are global. But for the mass market, the telcos are critical for the communication, and mobile communications have been filling those gaps already. And I'll pick up from Anirban the standardization that has been already seeing the two communities coming together and discuss, and I fully agree with the Comtech keynote that we're not even saying why we're doing it, we're already doing it. We're already discussing technical challenges and writing common specifications. 3GPP is an example, but Diffie with a detailed presentation is another example, very concrete on relying on virtualization. And all these are accelerators, enablers for the convergence between the two.
Yep.
Knowing that we have somehow agreed on the past convergences that we are building on,
Yeah.
the software and network, the IT cloud network, the continuum, the new use cases that are enabled for all industries by 5G and software infrastructures. So it's just confirming all these technology trends and building on them from the satellite perspective.
Rika, I know you come at it from maybe a slightly different angle, but how do you assess the last year and what's really changed for you?
Well, a lot has happened in the last year. I just want to first thank the GSMA for this program. It's as popular as it was, I remember, last year, so amazing to have this opportunity to talk about various topics in the space domain. At NTT, we are across a number of different emerging technology pioneering initiatives in partnership with private and public partnerships. And I think that's one fulcrum here is the acceleration of private-public partnerships. I attended a space symposium in Silicon Valley several months ago, and a general on stage basically said, we can't do this alone. The Space Force and the US agencies need to work with private sector to be able to keep up with the pace of change and the speed of innovation that's driving things forward. I think a lot of that is enabling access to be much more democratized. Not enough yet, but I think being able to be democratized across regions, so you see a lot more of the global community starting to come into the domain. And conversely, that's creating, I think, that over the past year, and given certain geopolitical dynamics that have been going on, is some concern around how the space frontier, which, as I was talking to a satellite provider, a dominant one, said 5 years ago, the space domain was fairly benign, and now we're having to think about how to have defense systems, not just to prevent jamming, anti-jamming technology, and as we just heard from Nadine in the previous talk around the encryption security, but also simply having satellites shot down by bad actors. And so I think there's this incredible excitement that has an undercurrent of nervousness and anxiety, and it's critical that global parties and players come together and really advance and take advantage of private-public partnerships to make this global community part of that fabric.
Round us out, Freddie. I mean, you come from Ericsson, so a vendor perspective here. We'll get into the device side of it in a bit, but how do you assess the 12 months, and how does Ericsson in general come at this topic?
Yeah. It's been an interesting year, for sure. Of course, we spend most of our time talking to mobile network operators. I think the change in the dialogues has gone from, how do we look at direct-to-device? Is this a threat? Is this something that we need to incorporate in our networks? To over the last 12 months, it's more about the how. It's a given that to reach limitless, ubiquitous connectivity, we need satellite as a component in that. Satellite connectivity is a great complement, but also, as mentioned, with some of the events we have seen, the need for a resilient backup is also very evident. And so many of our MNO customers are now coming to us saying, how do we design the future networks where terrestrial and non-terrestrial networks can coexist? Yeah. And of course, we have spent many years in standardization, figuring out how to make the coexistence work in an effective way. We're now seeing real momentum behind how do we actually build this system? How do we make the transition into a release 17, 18, 19 based satellite system? So very exciting year. I also think, of course, the fact that we have proven that we can do this with existing devices and that we can reuse the installed base has further increased the momentum, and there's no doubt. But now I think it's really how do we now converge into a solution that will take us into the future.
And that's a good segue, and because I want to get into the direct-to-cell, direct-to-device story here. I think a lot of people are following that really closely and want to understand, the implications of that and how it plays out in terms of when this service is going to be in people's pockets. Scott, AST has been super active the last year. First satellite launches, big plans. Can you, how do you see the direct-to-device opportunity playing out, and what are you hearing from the operators that you're, discussing this with? How are they viewing this as going to be used by their own customers?
It's a great question. And so to date, we've launched 5 commercial satellites. We're starting to do kind of beta service with them in the United States and a few countries in Europe. And we just did some high-profile video calls with Margarita, the CEO of Vodafone, as well as our partners in the US, AT&T and Verizon. So that's meant to convey that this is cellular broadband capable, and that's for us where we're going. Our entire architecture from 7 years ago was designed around that outcome. I think what you're seeing today is the initial unlocks of how do you make a direct-to-device service go over the consumer market. You're seeing text services, you're seeing SOS services, and as we start to go to market with initial services late this year, and then with more robust services in 2026, this is something that we're going to be coming with the whole cellular native package. This is not, for us at least, this is designed to work with the RAN of the customers. This is designed to work with mobile network operators broadly across all of their applications. And it's up to them and us how we go to market with that. But being cellular broadband capable is very important. We feel that that's how you deliver more value to the 5 billion plus users of cellular today. And then ultimately, in partnering with the operators, how we capture some of that value. And so that's our strategy. That's how we monetize it. And you see it playing out actually in Europe directly with the expansion of our Vodafone partnership this week, as we announced a joint venture to not just go after the 10 Vodafone home markets, but expand across Europe with a sovereign European capability that takes traffic up and brings traffic down within Europe.
Yeah, and we're gonna hear a lot more about that. Anirban, I mean, how do you think about direct to cell? I mean, does what Scott's saying, does that resonate? Do you think there's any other things we should be thinking about in terms of the commercialization of this technology?
No, absolutely. Scott is on point. Direct to cell, paves the path to ubiquity, and I think the best use case for this is emergency calls, and we have certain number of unserved and underserved areas, not just in North America, but across the world. So direct to cell is definitely needed. I think while the use case is certainly acceptable, I think the ecosystem needs to come out and also start looking into next gen services. So today we are just restrictive towards text.
Yeah.
We have to get to next generation voice and data. Yeah. We also have to ensure that the customers who are switching from terrestrial to NTN, they retain the same user experience or customer experience at the end of the day. And I think a whole lot of network engineering and planning needs to happen. Folks from both sides of the house, and I'll say actually three sides of the house, who are the ecosystem players here. I mean, it's not just the device manufacturer, but also the mobile network operators, the satellite operators, and the technology providers whose technologies are getting into these operating segments. They all need to come in together to create this, because one of the key things here is not just giving the ability to provide an end-to-end service, but also making the system resilient, ensuring that it has the kind of availability that the user is, usually takes it for granted, but obviously raises a flag if something goes bad. So I think direct to cell is here. People are excited, but I think we have a lot of work to do in our future.
Amina, do you want to weigh in on that one?
Yeah, I think it confirms it's somehow the solution, the technology solution for the seamless mobility. It's already there from the telco side. Roaming is a reality, and we're all happy it's there. The cost, though, of the devices for the mobile networks is lower than the cost for the satellite devices. And this is thanks to standardization, thanks to the innovation that happened already from the chipset side. Bringing this to the satellite connectivity would just allow for mobility for maybe the same users, but adopting the wideband 3GPP devices. It won't happen overnight, that's for sure. But if we look at the first use case, it would be more low data rates, right? And IoT, as mentioned. And we're already dealing with this. Well, MSSA, for example, the organization is looking already at the use of L and S bands, and it's there. Yeah. Both satellite and telcos are discussing in that forum. Yeah. In 3GPP, we're looking at the UE, SAT-UE. Until now, for scenarios where the terrestrial network is not available, yeah. So that would be more crisis management or disaster management, and it's an answer. Mission critical ecosystem is the first one to be adopting it. They already have handheld devices that connect to private 5G networks. Yeah. And wherever they go, and usually they are first responders, so they are in emergency response, right? They would use any available network. So on top of their onboarded, I would say, private networks, that would rely also, and depending on the area where they are, urban or rural, they would rely on satellite connectivity, but that would happen only if their device is already enabled with this. The bottleneck, though, is definitely the spectrum and the business models. So maybe we'll touch on this later.
Yeah, and we'll come back to the commercialization timelines at the end, because I want to give the audience a sense of how we expect this to play out. But maybe, Rika and Freddie, if we can slightly pivot the discussion to the enterprise side. We talk a lot about the consumer dimension and direct to cell, which is applicable for IoT, of course, as well. But we put up. I put up a slide showing the different industries, the B2B side, that satellite can potentially service. How do you think about that? Like, do we think this is this real? And how does satellite help these industries over time? How do you think that plays out?
Yeah, we're very excited about this, and in fact, we've had a service in NTT has had a service in Japan domestically called Widestar since the mid-1990s, which is satellite telephony that we've had. So we've been investing in this space for decades now, if I can say that. And then earlier this week, we announced a world's first. We had a high-altitude platform system, a HAPS device, in collaboration with partners that we flew above Kenya at 20 kilometers, wow, and were able to successfully have it connect to a cell phone LTE on the ground. So we're very excited about that, and the plan now is to have the HAPS device come to Japan and to run further testing, and hopefully we'll be able to share outcomes around that. And specifically why we're doing this is because we do see applications and use cases in the domain of agriculture, mining, ports, shipping, maritime, every sector, and in fact even some sectors that if you interlace some of the connectivity with the other side of space and satellite around Earth observation, starts to really yield an incredible dynamic digital twin of an ecosystem, and to be able to have a direct-to-device connectivity interlaced with Earth observation, and then being able to provide that to enterprise to be able to manage, have resilience, manage climate change, and also infrastructure management, vulnerability management. Some of those things are areas that we're incredibly excited about, and not the least of which, of course, when we think about direct-to-device, so whether it's a HAPS at 20 kilometers or multi-orbit, as that was already brought up today, we at NTT have this vision of a space-integrated computing network. And so for us, it really is about extending what we do terrestrially, which is connectivity, data, and intelligence, and extending that digital fabric into multiple orbits. Yeah. And so we are also looking at other areas where enterprise are going to win in the domain of connectivity, not just in cellular connectivity technology and RF, but we're also advancing this notion of optical data relay, which is extremely exciting because that, again, is about higher throughput, lower latency, much more secure network running with optical data relay. And so we're investing in this space specifically because our enterprise customers, primarily through our NTT Data group, we have a booth here with that team, are servicing those industries. And their interest isn't about necessarily the technology, their interest is about seamless connectivity and outcomes. And so being able to enable remote areas where there is no connectivity for emergency response, but for even mundane use cases like simply having access to enterprise applications to be able to enable the workforce to run seamlessly. So yeah, we're all in on enterprise.
Yeah, it's really interesting, and I'm glad you brought up the multi-orbit point. The whole constellation architecture is actually something we'll probably get into in the second panel, because it's easy to forget when you talk about NTN, we think about satellite, but that does include other vehicles. It includes HAPS, all of which deserve to be in the conversation. Freddie, I mean, Ericsson is a cellular pioneer and has been for as long as we can remember. How do you think about this sort of IoT dimension and the B2B dimension? Do you see that as an opportunity? Do you see it as a risk? Talk us through that from your perspective.
So, building a little bit on the idea of limitless connectivity, I think it's, at the end of the day, we need to build a ubiquitous system connecting both consumers and enterprises, devices and people, and doing that in a seamless way. And I think it's very clear to us and to our customers that the only way to do that in a reliable way is with a hybrid network with multiple different types of networks coming together. But also then coming back to the importance of converging, integrating these networks for end user experience, for effective handovers between the different networks, and for predictable performance. And I think when it comes to enterprise, the big difference really comes back to the predictability. Can I design my applications for a predictable connection wherever I am? And I think the interesting thing is, if you cannot do that, you will find other ways around solving the problem. You will make your applications less dependent on connectivity. You will maybe find different solutions. So different to consumer, there's a little bit of almost a binary logic to enterprise. You either can rely on the network, then you build your applications based on that, or you cannot. And I think we're really at the point where we will see a lot more innovation in the enterprise space when connectivity can be relied on and with a performance that is predictable.
And just a quick follow-up on that. So like if we're talking about, let's say we're talking about in the agriculture and mining industry, and we're talking about operating a drone over a field or a mining pit to survey it before the team goes in to carry out maintenance or something. Is there currently enough satellite bandwidth and capacity to do that? Or do we still need to see more improvements on the technical side to facilitate that?
So I from an Ericsson standpoint, we look at the combination of the terrestrial and the non-terrestrial network and how the two together can serve the needs of remotely controlled drones or mining equipment and so on. I would argue we still have gaps. We still have work to do, both in terms of technology, the spectrum, and also the device side, to be able to provide the reliable and the predictable capacity needed. But I think we are progressing much quicker than most people thought only a few years back. Yep. So we're soon there, and we're soon able to provide that seamless connectivity that is so crucial for enterprise.
So we've got about 12 minutes left, and I want to talk about sort of the commercialization roadmap and a little bit on the outlook. And I'll come back to you first, Scott. I mean, you've got ambitious plans. You've got your first satellites up in the air, plans for more. Can you talked about the Vodafone partnership and others in the US. When can people expect to see services being available using AST's satellite? And secondly, talk us through if there are any modifications that need to be made to the device, or if it can just be, the service can be used as is.
Yeah. So when we started this about 8 years ago, there were some preconditions. You can't change the device, and you have to work, and you have to find spectrum.
Yep.
And so since then, there's been a lot of evolutions in the marketplace that we've taken advantage of. But still, our core strategy is don't change the device. Yep. And leverage spectrum. And so we can do this because we have the largest satellites in low Earth orbit today. They're about 65 square meters. Our next generation one being launched in Q2 is about 200 square meters. So these are really, really big satellites that facilitate a lot of things, including phones that work without having to wave at the sky, phones that can get cellular broadband capable connections. We've already tested 20 megabits per second on a 5 megahertz allocation. So it's really us, we're about providing as much flexibility in the in-orbit architecture that allows the ecosystem to participate in that, and ultimately the service provider, the operator, with whom we're partnered with about 50 globally who cover almost 3 billion subscribers. These give them as much flexibility to go to market as possible, because what we know is that there are good use cases in killer apps and this and that, but at the end of the day, what the operators have done for the consumer mass market of available information, putting the world's information in our pocket 95+% of the time is amazing. And still we're upset about it. Still we want more. And one of the things that our layer does is it allows the consumer to fall back in love with connectivity through their service provider.
Yep.
And being able to do that is critical.
Yep.
And for us, in terms of timeline, we're launching more satellites this year, but we're rolling out a closed beta in the United States with Verizon and AT&T soon. Yep. And that will basically do cellular broadband to a regular unmodified phone with no changes required on the phone, but for a limited time frame, less than an hour a day.
Yeah.
And as we launch more satellites, we can enable more of a continuous service.
Yeah.
And we'll start with services later this year that are more public, and then in 2026, that's the big open.
So any device
Any
taps
device.
into it right away.
Yep.
That's super interesting. Anirban, how do you think about this question, like looking ahead, commercialization timelines, as you start to get more satellites being launched from various providers? When do you expect to see mass market availability of this technology for people?
I think about 3 years is when I would forecast. We have still some work to do.
Yep.
I think the industry has proven that this can be done. There is the art of the possible. There are other things which need to be resolved from a technical standpoint. For example, to Scott's point, the new satellites, what is the kind of payload they are sending? Is this 5G new radio? Is it just the whole GNB or the split DU model? What's the payload's power consumption, and how do you manage the total cost of ownership? And I think these are some significant questions that need to be answered. Then on the ground side, it is also important to when we are stitching these partnerships, there is this whole question of system integration, right? So a satellite operator with a mobile network operator, this system integration has to happen, especially because this is the very first time we are amalgamating two very different kind of silos into one. So I think it's 3 years. And last but not the least, latching onto the question that you asked on the IoT, the device ecosystem needs to also come up. I mean, it's not just direct to cell. If we are saying a true 5G NTN offering, IoT is a salient piece of it. I mean, utilities, agriculture, etc. I think the device ecosystem, even for native 5G terrestrial today, if we talk about true MMTC adoption, that's not very high because, again, the battery life, the power consumption, and all of those things are important along with the price of that particular chipset. You alluded to 5G on the RedCap side, and I think RedCap does have a promise, again, bringing back to the 5G NTN scenario, especially in the IoT module. So I think the device ecosystem, what is in the payload, and last but not the least, the integration of terrestrial and non-terrestrial. These three salient items need to be hashed out, worked and reworked, tested, and I think about 3 years is where I would say the first commercial, true 5G NTN.
So we got just over 5 minutes left, and I want to give each of you guys a chance to weigh in on this as well. There's a technical dimension to this. There's obviously just a practical dimension of getting the satellites into the air at a certain volume that will allow services, Scott said, to move from sort of 2 or 3 hours a day to 24/7 coverage. Amina, when you look ahead, does that timeline make sense to you? Do you think it's longer, 2-3 years? And what do you think kind of drives that? And then I'll come to you guys, so maybe just 2 minutes each.
I really believe if we don't want to build solution in the satellite industry, at least to continue to be to have the vendor lock-in, we definitely need to align with the standardization timelines, right? So I think somehow don't have the choice than going and speak to each other, work together in standardization bodies, but also for maybe for the speed that we want to meet the market needs. We can go with de facto standards, like everything. I would mention ORAN, for example. Yeah. ORAN and 3GPP are talking more and more because ORAN managed to accelerate some architectural aspects that are now being adopted by the market, and they are all software-based. So it's another approach of doing standards. They are not official standards, but they're de facto standards that we need to integrate in parallel to what we're doing in standardization. So in general, alignment with standardization bodies, and 3GPP, again, is just an example, a big one, but TM Firm, for example, for everything standardized and APIs and new services, exposure, multi-provider infrastructures. We cannot afford CapEx for all infrastructures, so that's why we should work together. I wanted to pick up the example of the HAPS in Japan. That's being commercialized in 2026. And it's release 17, and the teams, it's Airbus and NTT Docomo, are working to implement on the same HAPS, the Alto HAPS, release 18 and 19 further. But now release 17 is implemented, and that's becoming a reality. Yeah. So we see the benefits. The message here is that we see the benefit of aligning with standardization and collaborating. It can be beforehand, before standardization, where we share views, where we build a common view and go to making concrete. But it's one example of success, I would say.
So I harken back to somebody said on stage last year at the SAT show in DC, they said, when the phone first ended up in the car, the executives sat around the table and said, what's the use case? Why would people have a phone in the car? Why would they use it? And somebody said, I know, got the perfect answer. It's real estate agents. That's our use case. And look at where we are now. So I think we don't even see what's on the other side of what's possible yet. And I think a major driver, as we heard from the previous talk, is also AI and the role that Gen AI is going to play around orchestrating a lot of countries now and satellite, the 1,000 sales program with China, and how many are going to be going up, and how many people believe in terms of at the LEO level when VLEO is coming on the scene. So for us at NTT, and thank you for the acknowledgement of the incredible partnership with Airbus on this, we're also working on the concept of inter-orbit connectivity. So instead of thinking about the connectivity down to Earth and back up and whatnot, is being able to have inter-orbit connectivity across satellites. And that then starts to introduce and fathom the concept of space-based data centers. Not the huge monolithic buildings that you see in Arizona and other places going up into space, but more onboard edge computing, AI, that's going to enable that space-based integrated computing network that we're envisioning and moving forward. So I don't know that I would put a timeline specifically on when is this going to be commercialized. I think it's going to be constant evolution. I think there's going to be more breakthroughs that we don't even see yet, so that we'll be able to go beyond just making phone calls from the car to sell a house.
Yeah, and I'm glad you brought up AI. I mean, we're going to, again, in the second panel, get into Gen AI. There's, obviously, that's a whole dominating issue right now, but I think that obviously has implications for the way satellite is run, and as you say, not just the deployment, but the actual operation of the service. Freddie, last word to you on this. We've got 2 minutes left. How do you think about the outlook there, and talk us through what you think the commercialization roadmap looks like?
Yeah, I mean, so for us, the commercialization roadmap started already back in 2022, to be honest. We've had direct-to-device services, messaging-based, since Apple launched their services. We now have messaging services live in Android, and so this has already started. We have already proven that we can do even voice, video, and broadband services on individual installations. When it comes to scaling, it comes back to available spectrum and capacity in the satellite networks. And that's not going to be something that all of a sudden just happens. It's going to be a gradual increase. It also will have device dependencies, especially on the spectrum side. If we're going to use L and S band to expand the capacity of direct-to-device, then we need devices to support those spectrum bands. But if you want me to give a year, I do expect the 3 to 5 year horizon to be when we see this not only available, but used by consumers all over the world on a regular basis.
Very interesting. Guys, thank you so much. We could, as I said last year, we could be talking for a morning on this. We're going to get to our next keynote speaker, and for all of you in the audience, we're going to have another panel shortly after that, so stay with us. But yeah, thank you very much, guys, for all your contributions. A great discussion.
Thank you.
Freddie, Rika.
Thanks a lot, Tim.
Thank you very much for coming. Okay. I know some of you are waiting out there, which is great. We can hopefully facilitate some of you coming in as others go. But I want to move to our next keynote. And here to join us from the UK Space Agency, hopefully ready to go, is Craig Brown. So please welcome him up. Hey, Craig, good to see you. The clicker's right there. Okay.
So, good morning, everybody. It's a pleasure to be here in Barcelona for Mobile World Congress and to speak to you during this summit. For decades, space technologies have shaped how we live, work, and understand our world. Today, our way of life on Earth depends on space. Thank you. Today, our way of life on Earth depends on space. Satellites enable our world as we see it today. Satellites enable data-driven applications to reach the most remotest places, keep businesses connected with their customers, and products and services moving. They give us the ability to precisely geolocate ourselves, predict the weather, and monitor our planet's health. Increasingly, they underpin global financial systems and critical infrastructure across the globe, all themes relevant to the Mobile World Congress. Satellite-based telecommunications is experiencing sustained and significant disruption from the rapid growth of low Earth orbit constellations and a shift towards data services. We're also witnessing the growth of new in-orbit regenerative processing and associated optical technologies, which will improve the data rates of signals transmitted to and from space. Together, these technologies will support the growth of new services, including direct-to-device and quantum communications. And these should, through partners such as mobile network operators, increase the accessibility and the commercial potential of satellite communication services and present real progress towards ubiquitous, seamless connectivity. The convergence between terrestrial and non-terrestrial networks will require further standardization. For us, standards are and will remain an integral part of delivering our vision of fully converging networks, including new end-to-end infrastructures. We are witnessing more and more systems being planned and gradually becoming operational. This will encourage diversity within the market, but to optimize such developments, interoperability will be key. In practice, this will mean that systems will need to be able to work together, and operators, along with other players, can collaborate. This convergence is not just a technical evolution, it's the result of anticipating the greater demand for spectrum and creating compatible, complementary services to grow the scale and scope of the sector. It's about unlocking new possibilities for communication, expanding access to how people live, work, and travel, and enabling innovative technologies to support a new phase in human connectivity, something many of us will understand only too well. Today, I would like to focus on the role of national space agencies in enabling some of these changes and the contributions made specifically by the UK Space Agency. So firstly, let me touch on the role of the UK Space Agency. Established in 2010, we are an executive agency of the UK government. Our ambition is to make the UK one of the world's most innovative and attractive space economies through catalysing investment, delivering missions and capabilities, and championing the power of space. Space is a sector within the UK which generates some £18.9 billion of income annually and employs 52,000 people, and indeed 17.78% of the UK's GDP, that's roughly £370 billion a year, is dependent on satellite services. Within this context, a key objective is to secure UK leadership in commercial satellite communications. Our priorities include economic growth, as space investments return nearly 10 to 1 in a global economy worth around about £490 billion by 2030. Enabling citizens' benefits by making space services work for people and businesses in the UK and beyond. Global influence through partnering on new missions and setting standards and for the benefits of all. And threat protection. So as you might imagine, space is part of the UK's critical national infrastructure. As Director for the Director of Investment for the UK Space Agency, my role is turning the objective to catalyse investment into a reality. This is about deploying our resources to multiply the value of non-government contracts and private capital secured by UK space organisations to maximize the sector's long-term growth. And we're pretty good at it. As a nation, the UK invests less than 1% of global government spend on space, yet we capture about 5% of the global space market. It's worth noting that we were the first national space agency to take a dedicated exhibition stand here at MWC, and we're proud to be taking this lead. So we're part of the UK Innovation Pavilion, which demonstrates the UK offer, so do come and visit us in Hall 7 to meet the team. We're not alone, of course, in representing space organisations at MWC, with our colleagues in the European Space Agency also having a presence in the conference. We work very closely with them and value this partnership in supporting innovation and technology development. As an example, around 75% of the UK Space Agency's national budget is allocated via ESA annually, and ESA provides funding through contracts to industry and academia, and facilitates access to large space programs, which would be a challenge to replicate nationally. A great example is the Advanced Research in Telecommunication Systems program, or ARTES as we know it. In 2022, the UK subscribed £190 million to ARTES. The value of this is clear when you consider the figures. Each pound invested by the UK in ARTES leads to a 14-to-1 return on investment to the UK in sales revenue, and this is something which we want to see continue. We also work with other international partners such as NASA, and these relationships allow us to deliver and facilitate collaboration in supply chains and operator networks to deliver things which might not otherwise be possible, such as in-orbit demonstrator projects for industry to use. National space agencies have long been at the forefront of space-based technologies, but our role is changing as we bring together terrestrial networks with satellite and other non-terrestrial systems. By leveraging satellite constellations and high-altitude platforms, we are ensuring seamless integration between ground-based infrastructure and space-based systems to provide global coverage. The UK has taken a proactive approach in supporting partnerships between space and telecommunications companies to ensure the benefits of convergence are realised. For example, we played an integral role in ESA's convergence-focused activities, such as helping establish their Space for 5G programme and supporting the 5G Emerge consortium in collaboration with the European Broadcasting Union. As the UK Space Agency, we're increasingly focused on supporting this convergence. We are contributing to the evolution of the UK as a hub from which global satellite operators can roll out their services, and where commercial organisations can develop the advanced payloads needed to operate these satellites. For example, the UK Space Agency working with ESA is set to provide funding to deliver future satellite services through a 5G private network for remote areas in the UK, including 2 trials in 2 of our islands in Scotland and in Northern Ireland. One of the key goals of this convergence is expanding global connectivity, particularly to underserved regions. Within the UK, Intelsat OneWeb satellite constellation aims to provide affordable internet to isolated areas. A demonstration of what such technology and supporting partnerships can deliver has been run just this week on ESA's stand. And this shows a live stream from a OneWeb LEO satellite linking MWC and an ESA facility in Cologne. If you haven't already, please do go and take a look. The UK's Connectivity in Low Earth Orbit programme, CLEO, seeks to hone the UK's competitive edge in satellite communication sector by enabling companies to diversify into the constellations market. Our first group of CLEO projects has kicked off and includes InSilica, developing novel silicon chips and software for a user terminal that will be compatible with UK and European constellations. Accelerate Technology, developing a small and flexible user terminal that will allow users to choose the operator and orbit via an app, reducing costs and enhancing global configurability. And Ramon Space, developing next-generation digital onboard processors for large-scale communication constellations. This demonstrates that delivering connectivity is not just about the satellites, but also the supply chain, constituent parts, and supporting services. Through such initiatives, the UK is helping to ensure that global connectivity is a rapidly approaching reality. Our strength in satellite communications is demonstrated by the presence of global operators. Through our interactions, we have seen that proximity and access to such companies provides real value for other organizations to drive integration of systems and services. Another area of significant interest and potential for the UK is the development of new technologies such as direct-to-device. This technology is game-changing and will make a real difference for digital growth and inclusion. This includes not only direct services to mobile devices, but also machine-to-machine links or the Internet of Things. Some examples of UK activity in this area include the following. On the 27th of January this year, an agreement facilitated by UK Space Agency support was signed between ESA and Viasat. This will explore a partnership to provide the detailed design and procurement of an open architecture LEO network capable of providing 5G non-terrestrial network services to mobiles. In January, Vodafone successfully made a video call using normal 4G, 5G smartphones capable of in an area with no terrestrial coverage in Wales. In January, Filtronic is developing hardware that aims to provide fast, high-capacity links between LEO communication satellites and receiving ground stations. And finally, Lacuna Space has developed sensors that leverage LEO satellite IoT technology to help with projects such as monitoring water quality. Other new technologies are likely to act as critical enablers for satellite communications, including quantum and AI, as demonstrated by their inclusion in MWC's themes. One example is ESA's Quantum Key Distribution Satellite, or QKDSat project, to which the UK contributes. Honeywell UK is leading an industrial consortium to launch QKDSat into LEO and will demonstrate how a space-based infrastructure using the laws of quantum mechanics can keep secure, sensitive information when exchanged between several parties. AI will also be a vital enabler for future network capabilities. A growing part of this is dynamic routing as network operators transition data with multiple complex pathways. We will increasingly see a focus on regenerative and optical payloads, all of which require supporting supply chains, an area which the UK is well positioned to provide, and this is why the CLEO programme focuses on 5 key technology areas which include all of these things. We're already seeing outstanding contributions from UK industry. There are too many to cover today, but they include from Archangel Lightworks, a deployable optical ground station enhancing satellite connectivity with high bandwidth, secure laser communication. This promises significant advances in connecting underserved regions, supporting applications from national security to disaster response. From Spire, optical intersatellite link technology for its nanosatellites to create secure, high-speed, laser-based communication networks in space. And this will enable much greater data transfer rates and reduce reliance on ground infrastructure. The future will also include convergence for systems on the lunar surface and deep space too. The lunar economy is growing rapidly, with over 400 missions planned for the next 2 decades, all of which will require reliable communications and navigation functions. ESA's Moonlight program will deliver the first commercial lunar communications and navigations infrastructure, which will serve multiple institutional and private customers. The UK will contribute to the end-to-end communication services, including space, ground, and user segments. The success of these technologies depends not just on innovation, but on the creation of clear regulatory frameworks that allow for the smooth integration of networks. Regulations and standardization will need to be the foundation of the technologies and changes I've covered today. It will only be possible to build these through responsible partnerships, which try to anticipate new developments and technologies. UK involvement includes working with the European Telecommunications Standard Institute on the 3rd generation partnership project that develops protocols for mobile telecommunications. Another major benefit of convergence is increased resilience. Space-based systems can be critical in a crisis. Satellites can act as a backup communication method, ensuring that connectivity remains available even when ground-based systems fail. The UK is delivering work to realise the benefits of this resilience. For For example, the UK Space Agency is actively supporting the development of Inflection, a project being delivered through a partnership led by AAC Clyde Space. This will result in a new satellite constellation able to provide real-time insights for entities in the maritime sector. So in conclusion, organisations such as the UK Space Agency are at the heart of convergence, driving innovation in global connectivity and cutting-edge technologies. However, this is all about partnerships. The UK can't deliver solutions alone, and we rely on our collaborations and investments with commercial and research partners, as well as international bodies, to make this a reality. As we look to the future, the role of space agencies will remain vital in ensuring that every corner of the world is connected and that the next wave of communication technologies reaches everyone, everywhere. Thank you.
Craig, thanks very much. Great perspective from the UK, and I think the public-private angle there is something we talked about in the first panel, and great to hear from you. We are going to move on to our next, speaker, who comes to us from Intelsat, and I'm very pleased to welcome Jean-Philippe Gillet to the stage, and after that we will move to our second panel. So Jean-Philippe.
Thank you very much. Thank you very much. It's very pleasing to see a full room. I remember 2018, we were the first satellite operator to come to Mobile World Congress with a big presence. And look at where we are now. There are people waiting outside to come in the room, and I think this is a dream come true for me. We have done a lot of work in the background. We talked about standardization. Mohamed is here with us. He was a key driver on talking 3GPP, the 3GPP language, into a satellite industry. And that's something that we have been driving for years. And I'm so pleased that we are where we are today, but this is just the beginning. I'm going to walk you through where we are today. I'm going to pick a couple of examples, and then I'm going to walk you through the first step of the vision. There is a lot of other things that's going on in the background that we are working on. But the success is the type of discussions we have with customers today. The success is not to talk about satellite connectivity. The success is to talk about non-terrestrial networks fully integrated into a terrestrial network. And that's really where the scale is coming from and where the difference is coming from. So first of all, let's use one of our customers today, service that we are providing. This is a service we provide in Japan. This is today. And Japan has been at the forefront of some of the new technology from a satellite standpoint, because the Japanese market needs to have a lot of resiliency. So this is a network we provide today. We have 2,500 sites. The network is fully managed by Intelsat. We have a NOC dedicated in Japan for that specific customer. On the 2,500 sites, we have a third of the sites that are fixed sites carrying live traffic. These are some of the most rural locations. We have a third of the sites that are installed in key locations just as backup. And that's going to be used whenever there is a requirement. If there is earthquake somewhere or another incident, then you use this capacity for the third of the site. And then there is another third of the sites of deployable terminal. This is really where you add additional capacity when there is a requirement for additional capacity. So that's a service we provide today. If you look at other type of applications, we also with the same mindset, provide end-to-end managed services where we integrate the ground infrastructure up to the tower. Using another example, this is a mining example. Again, something that we provide today. Two types of connectivity. Connectivity on moving vehicles, where you have a flat panel on a vehicle that moves, that wants to be connected all the time. That could be automation, that could be remote monitoring of the equipment. That's also providing Wi-Fi hotspot or 5G, private 5G. This is a big application that we are driving on the mining sites, for example. So this is today. Today has a lot of limitation. And this is where we are going to see how we are transforming this for the future. And the future is going to allow us to scale. And when we think about where we want to go in the future, the way we look at it is we look at our customers, the mobile network operators. How do we create a future that allows us to scale with the mobile network operators? Today, we provide services mainly on one single orbit. Geostationary is what we are doing, but it's one orbit. This is hardware-based. And I think this is really something which is key, that the satellite industry has very often used proprietary standard, which is not standard if it's proprietary, and then hardware-based solution. And if you want to scale, you need to transform this. How do you transform this? You transform this using multi-orbit, software-based solutions, and an open standard. For anybody that's in the mobile network operator, this is obvious. For anybody that's coming from a satellite background, this is a journey for all of us. But we are embracing that journey, and we are going to make it happen in a way that's really going to help us scale with our customers. So what does that mean in concrete terms? That means that the services that we are providing are going to be application aware. And that's really where this is going to make a huge difference. We do not believe that there is one orbit, one solution that's going to serve all of the requirements. We do not believe that a solution which is based on a specific standard that's used by the manufacturer of the service provider that's putting together the satellite solution is going to be fully integrated into mobile network operators. So we really believe in multi-orbit with an ability to do roaming, and also I'll use a specific use case for capacity on demand. So this is where the market is going to evolve from what we are providing today to the next generation of services of non-terrestrial solutions. So what does that mean, application aware? Application aware really means that you are able to route the traffic on the best support. The best support which includes multi-orbit, but which also includes an ability to route the traffic where you have the best economic, the best security, you have a reliability, which is important, latency is going to be important, and the best orbit, of course. More than 70% of the traffic today on most of the mobile network operators is video traffic. Do you need LEO latency for video traffic? There are some other applications that are really best suited for low latency services. And that's the way you are going to manage this in the future, with the ability to route the best application on the best support. In all of that, in order to make it work, you need to have a smart edge. And the smart edge is the tool that's going to help route the best service on the best support. And that's where all of the developments are going to be put. There is no good presentation at Mobile World Congress without at least mentioning the word AI. That's where AI is going to fit for us. This is where you learn about the way the traffic is currently being distributed, and you are going to learn and then use that in order to optimize the traffic further. Again, we don't believe in one orbital slot. All of these orbital slots have different benefits. GEO has the benefit of providing a wide coverage. You can cover the world with a very small number of satellites, and the next generation of GEO satellites will also be software defined, an ability to change the configuration of the satellites in order to be able to assign more capacity on areas that have higher requirements of throughput. And the next use case I'm going to talk about is going to give you a good explanation or a good way to demonstrate why that would benefit. MEO, an ability to cover the world with greater number of satellites, but still a relatively low number of satellites, and an ability also to change the configuration on the satellite in order to adjust based on where you see the most demand. And LEO with low orbit, low latency, and higher throughput in some areas. It's a combination of all of that that's making the services extremely powerful. Capacity on demand, and this is where, if you think about the first use case I mentioned in Japan, where disaster recovery and ability to provide services when there are areas that require very high throughput, it's extremely important to find a way to resolve that. If you combine these three orbits plus the next generation of software-defined satellites that are currently under construction for GEO, then you have an ability to transmit and to allocate more throughput in an area that has the highest demand. Imagine today, if you have an earthquake or if you have a disaster, suddenly you have all of the emergency response teams that are coming to the same location in a very short space. And at that time, you tend to have congestion simply because all of the satellite solutions are being used by the same people at the same time. If you have, in addition of, you can layer on some GEO services with software-defined solutions, then you are able to allocate more capacity to that location. And this is what makes it very powerful. You can pull more capacity where you have more demand. And this is really where we see the future. The future of NTN is something which is very simple and very easily understood by the mobile network operators. It's about roaming between satellite and terrestrial. And the roaming behind the scene is extremely complex, but for our customers is totally transparent. I use this as part of a presentation that we do with one of our customers. We have signed an MOU with SoftBank in developing the next generation of services. Imagine a car moving from an area where there is coverage, terrestrial coverage, to an area where there is no coverage. The future is the ability to roam the same way you roam between different mobile network operators, you would be able to roam in a transparent way between mobile network operators and satellite connectivity. So this is what it is about. It's about developing a ubiquitous network. This is about developing a network which is satellite complementary to terrestrial solutions. This is about using the standardization that the mobile network operators are using in order to scale. Today, we see a future where we believe that our services are going to be integrated with the majority of the mobile network operators as a way for them to expand, as a way for them to increase their reach and to generate additional revenue for their customers. And all of that comes with standardization. All of that comes with a set of services that will make it totally transparent for our customers to roam from terrestrial to non-terrestrial solution. Thank you.
Thank you very much, Jean-Philippe. Great insights as ever. Okay, I mentioned before, we are going to move on to our second panel. Equally great. Really excited to have all these great speakers here. So if I can welcome them up to the stage. David Goldman from SpaceX and Starlink, Mohammed Marashi from SES, Anche Williams from Deutsche Telekom, Sunil Patel from Qualcomm, and Julie Kearney from DLA Piper.
Yeah.
Hey, I'm so glad.
I said that was leading the world.
How are you?
It's good to see you. Hi.
Nice.
Such a pleasure. Great to see you.
Everybody get comfortable.
Hey, how are you?
Going shopping. It's Barcelona.
Guys, thanks so much for being here. And super great to have you up. And I think everybody's going to be interested in your perspectives. I started the first panel, and the first panel we talked a lot about satellite telco convergence. We'll talk a bit about that for sure, because we've got different perspectives here. I also want to get into the innovation pipeline and how we expect satellite service to change over time. And then, bring in some examples from your own experience to sort of talk us through how things are going and what that means for the future. But I do first want to ask all of you, and just if we can keep our answers brief so we can get through as many questions as possible, the same question I asked to the first panel to start off, which is, in the last 12 months, what do you think the big things that have changed are that have really driven the momentum in the satellite sector and especially the telco-satellite convergence? That's what I want to start off. And Anche, maybe I can start with you from an operator perspective. What do you think the big changes have been?
I think we are seeing things become more real. So basically, you see a lot of announcements that people are doing something with satellite technology, and at the end, we need to come from a lot of testing and trialing into something commercial, and that's what I think the main difference to a year ago.
So kind of moving from pilots into actual deployments and bringing this to reality. David, obviously you work for one of the preeminent companies in this space. There's so many bad puns when you have to use space as an industry. It just kind of happens. Sorry about that. How do you reflect on the last 12 months?
Well, we got to launch our service with the bad puns. Sorry.
Continuing on a theme.
I thought that was going to go better.
Yes,
Sorry.
I'm laughing.
We're good.
Noted.
Sorry. So, from a year ago, this has been like hugely transformative. Everything has changed. We've seen, like on a regulatory side, we've seen the first sets of regulations to allow satellites to work with devices. Julie led the Space Bureau at the FCC to put together some pioneering rules that we're now seeing lots of other countries starting to take it on very quickly. From a SpaceX perspective, in the past 12 months, we've launched over 500 satellites that have direct-to-device technology on it.
Yeah.
We now have commercial service on in the United States, in New Zealand. We have customers using the service on their phones that they already had in their pockets. That we're seeing in emergencies, we've been able to turn on, have hundreds of thousands of text messages go through, like within hours of a natural disaster coming through. So I think, and we're still only at the beginning.
Yep.
So this past year has been, I think, completely transformational, but we're now kind of at the starting line.
Just to get us to the starting line. Mohammed, do you want to give your thoughts on that?
Yeah, I think so. The past year has been extremely exciting. We've seen the adoption of space like I've never seen before, right? By the MNOs, it's just become significant. And there's been a lot of talk about some of the AI and so forth. And in the last year, we've actually started to implement those applications, and we started with the cruise. But just to see those actually work, and it's not just hype, it's actual practical implementation of services, and Nadine referred to it earlier in her talk, what we're doing there. So those are the very exciting stuff that's going on.
Julie.
Thank you. And thank you, Tim, for having me on the panel. Thanks to GSMA. Thanks to this full room. I had the luxury of serving as regulator in the U.S. at the Federal Communications Commission as the first chief of the Space Bureau. And as David mentioned, we were able to issue rules for supplemental coverage from space to marry satellite with terrestrial. So I'd say from my perspective, we've grown from aspiration to expectation. And what we're seeing in the U.S. with other governments like Canada and others around the world, we're needing to deliver this service. Consumers know what it is, and they have a great hunger to be connected, and I think the future is really bright.
So, you come from the vendor perspective here, which we're always interested. We want to get a diversity of voices. Give us your thoughts. Major changes last 12 months.
No, sure, yeah. I think as Qualcomm, our goal is really to bring these technologies to devices, and we work with as many partners as we can to enable multiple solutions. So I think in the last 12 months, David already mentioned, I think some of these SpaceX direct-to-cell services are already enabled on Qualcomm devices, but we've also helped ecosystem commercialize NTN solutions on Samsung Galaxy 25 in the US, so that took a lot of effort. So again, I think we are really excited. Like in 12 months, we are seeing these services in hands of consumers, so that was very exciting.
Yeah. There's no question, the interest and the buzz around this show and others obviously got SATCOM, and it is continuing to just sort of rise month on month. Let alone year on year. So there is so much happening. Within the direct-to-cell space, that has been one of the biggest sort of focus areas, I think, from a technology and a business perspective. David, obviously you guys are running that model. How do you see that sort of, from your experience so far and the partnerships that Starlink has formed, how are the operators you're working with responding to that? And how do you think that translates into a practical benefit for their customers?
So it's been great. Working with the partners has been terrific. I think like dead spots, white zones, dark, that has been a problem for everybody for a very long time. That's been a really tough nut to crack. And so far our experience with our partners is they're thrilled to be able to kind of say, we finally have that problem solved. It is important to say, this isn't 5G. I know there's talk about video calls and stuff, maybe one day, but that is not what's happening right now. It's, we're messaging, but when you need connectivity, getting a message out is critical. And so far our experience has been great. We partner with One New Zealand in New Zealand, their network covered 60% of the land area. Now they can reach people everywhere. And a lot of that is rural and hard to reach. And so having connectivity, having some way to call back in those areas it could be life-saving for people. So we're really, really seeing the effects like immediately on this.
And Antje, from your perspective, I mean, Deutsche Telekom is a major tier 1 carrier with operations in many, many countries. How do you view the direct-to-cell opportunity? How do you size that up?
I think for us it's very important to differentiate a little bit on global different countries and different coverage situations. So what we have as Deutsche Telekom and including the T-Mobile US, of course, we have different coverage situations in Europe and in the United States and in New Zealand as well. So the moment the coverage has big gaps or areas which are on top dangerous maybe that everybody needs an emergency service, you have a different need to have direct to handset as well as you probably have in Europe, where at the moment the German LTE coverage is 96%. You're talking different gaps. You still, at the end, it's important to have something 100%. That is what our target is, and that's the way we see it. So we are very proud network operator. We like to have satellite on top of what we have already today. And there are different solutions. And there's direct to handset, but there's also backhauling, for instance, for our mobile stations, that we can have an extra mobile station, and then we have a backhaul over satellite. And we do try different satellite solutions. I don't know if you've probably seen it. We even use a geo satellite in order to send out an SMS. Why? Because Europe has the advantage and disadvantage of having many, many countries, many, many borders. And when you use operator spectrum for direct to cell, you have quite a gap on every other border. And that makes it more difficult for us in Europe than it is in the United States, where you have two borders where you have the gap, but the landmass is way bigger. So I think we need to have a little bit of differentiated look, and I'm very happy you asked the questions, because I'm trying to always separate those topics, right? And
And I'm happy you raised that, because I was going to jump into that we have different satellites offering different services, and I think, David, the differentiation is really important among what the capabilities are, but they are growing, which is amazing. Globalstar, Apple, the partnership there, and the investment that Apple's making in Globalstar to make sure that people are getting service, and David, Starlink has led the way, and we're just, it's really exciting, and the innovation continues to iterate. So.
Yeah, and we'll hear from Globalstar shortly after this panel. I think, Mohammed, maybe coming back to you, I'm interested in the sort of when we look to the satellite performance, and not to get too technical, but I think David mentioned that it's still a texting story right now. There is a potential roadmap that changes to incorporate more functionality, potentially voice and potentially data in the future. Not sure how long that takes, but what do you think are the key enablers that we need to be thinking about to improve the service quality?
Okay, so I won't make it technical, but at a very high level, there are 5 key levers if you want to improve the performance, okay? One is that from the satellite perspective, you have to have sufficient power to be able to support the service. You need to have sufficient antenna gain on the satellite. That's why earlier Scott was talking about the size of the antenna that was larger. Third, you need the receiving end. you need to have high performance on the receiver. So that's an area, by the way, there hasn't been a lot of conversation around. But there is things that could be done in the future from an innovation perspective, not just on the satellite side, but also on the terminal side. And then you have the distance, the path loss. Every time you cut the distance in half, you gain 6 dB of path loss advantage. So if you go from, say, 500 kilometers to 250, which is near VLEO as an example, you gain 6 dB.
Mm-hmm.
Okay, and so on and so on. So all the way down to 20 kilometers, let's say, for the stratosphere. So you can see these gains. And then, of course, the last one, the spectrum.
Yep.
Mm-hmm. So those are really the 5 key elements, and we see innovations in each of those areas that need to happen to come together to really deliver the future in terms of more broadband type of applications and be able to address what you just brought up, something that is similar in performance that the MNOs are providing terrestrially. I do see that possibility there, but it's all the different players working together on each of those elements, from regulatory all the way to the terminal side, to make this happen.
Sunil, do you want to chime in on that?
No, yeah. So one thing as we just mentioned, so there is expectation that these services the performance needs to be similar to what MNOs are able to offer today, right? And that brings a lot of new requirements. I mean, I'm saying even just from device perspective. And because device ecosystem is a little bit different. Even if we say like, hey, we could put better antenna on a device to improve performance, but that needs to fit in the form factor. Plus, you're talking about tens and millions of, actually, many more millions of devices, so the cost becomes very important. So that's one aspect. The other is, which I always bring up in these discussions with our partners, is each service, and whether it is messaging, just data, voice, or video, each one has very stringent, as you start to go, up the stack, or as the requirements get very stringent from, for voice and for video. And I think that how you offer that over, direct to device, over satellite, I think it still needs some more kind of investigation, how we do that. So that is one area I think we still need to kind of focus on. So.
Julie, you come from, as you say, a sort of regulatory background, and we're really grateful to have your expertise on that here, because I know that it can be complicated when we're talking about this stuff. I put up a slide at the start in my opening remarks to sort of outline the different spectrum strategies that are possible here. Talk about how we should think about that here. I mean, we've got the MSS sort of camp. We've got the repurposing of terrestrial spectrum. What are the key things we should be thinking about there?
Yeah, I think as a regulator, a previous regulator, the key was to try to look at the available spectrum to work not just in the US, but globally. We've got the ITU as well. And I think we have companies like Kuiper who are innovating with the best and most efficient way, along with Starlink and our other players in the sphere. I think understanding what spectrum is available and what the horizon can be, and working closely with the regulators and the device manufacturers, but I think we have to be creative, and I think we need to look for areas where we can repurpose. I know that we're doing that in the US as much as possible. David, I'm sure you have a lot to add to that, but I think ultimately we're dealing with a finite resource in infinite space, but consumers have an expectation that they're going to get a service, and it's up to us to let them know what they're going to be getting, but to continue to iterate and to make these services available and not lock ourselves into the current ecosystem. I hope that helps.
Yeah. And And actually, just one quick follow-up on that. Like, do you think that those questions are broadly similar depending on the country you're looking at?
I think.
Yeah.
Yeah,
Okay.
I think so.
Okay. David, coming back to you, so your partnerships involve, reusing the spectrum that is licensed by the mobile operators. From a how do you manage that to ensure the service quality and the integrity of the service? And also, can you speak to, how does that impact Starlink's go-to-market timelines, or is it broadly sort of a streamlined process?
Well, each one is its own thing. And so the important points for us are the model that we're using. And I guess to get to Julie's point, like, it's great that there's all these different models that we're all looking at, right? Like, I think we're in the nascent stage of all of this. We don't know exactly what business models are going to play out over time, exactly what spectrum rules are going to play out over time. Let's all do it, and we'll see how it goes, and we'll see what ends up working. But so as we're working with our partners, the model that we're using, the end users are their customers.
Yep.
And that's critical for us. We need to make sure that what we're doing is making them look good, is making sure that our partners are delivering the quality of service that they have promised to their customers. So each one is a different situation. And so the interaction ends up being a little bit different for each one. But the technology, at this point, like, we have deployed the initial set of satellites where we can actually have a continuous service going. The issues end up being similar, but each partner has their own needs. Their situation is a little bit different. The border situation, we have to take it into account.
Yep.
So in the United States, we have one continuous border with Canada, one with Mexico that we need to roll off to. For European partners, we have to make sure that we're managing and we can work for their entire, tougher borders to deal with, but we've had to figure that out to make sure that for our European partners, that we're making sure that we can reach every corner of their country without causing cross-border interference. That's a hard problem. I think we've cracked it now.
Yep.
But that means that every partner kind of has their own issue that they're dealing with. And it's our job to make sure that we're working closely with them. I don't think it's really been slowing down on the technical side. It takes a little while to integrate everything, but so far we've been able to roll out relatively quickly now that we have the satellites up.
Mohammed, do you want to carry on that? Because there is an important point about service integrity. In other words, being able to operate where you're licensed to do so. How do you think about this question of that and how it impacts go-to-market in different countries?
So with regard to the slide that you put up on the MSS side and sort of sharing with the MNOs, we think both make sense. It's the right approach. There are pros and cons, obviously, to each one. The sharing, you take advantage of what already exists, all the devices that are out there. And so I think the recent stuff that's taken place in the US and in Canada, that makes sense and probably will happen elsewhere. And on the MSS side, the disadvantage, of course, is that the current equipment is limited in the ecosystem that can support those frequencies. But that can be, obviously, with time, can be resolved. But then there's the whole discussion around the allocation of spectrum for MSS, and that's a whole other topic I'm not going to get into, but I think that's, from our perspective, we should pursue both paths.
Anchi, coming back to you, I mean, again, we talked in the first panel about some of the use cases between targeting consumers and businesses. One, I think the interesting things that has emerged in the last year is the use of satellite for disaster recovery and emergency response. Do you want to give some thoughts on how Deutsche Telekom approaches that and how you see that?
Yeah, and I would like to broaden the question a little bit beyond only direct to handset, because we see a similar situation for the broadband services. A lot of customers are asking us for kind of a security belt. right? So they want to buy a bundle of connectivity. They don't care too much where it comes from. And I mean, I've seen these pictures before in a presentation about different orbits. I think it's a similar idea to say, okay, I want my customers to be happy. When you look at B2B customers, it could be a supermarket chain, right? So of course, they would like to have super connectivity in their supermarkets, everybody using their phone, asking whether they missed something in shopping. But the most crucial thing for the supermarket chain is the cashier and the door, right? And then I look at a satellite connectivity, which is probably from a capacity perspective, a little bit more limited, but the cashier in the door still would work, right? And then they can make business, and whether the people can still call home for the latest recipes is probably not that important. Yeah? So that's a little bit the way we look at it, and we see that the demand is increasing to say, look, I want it all, and I want you to give me on top a backup system. And then I have these situations where I have 35 supermarkets, and one of them is out of order, right? Is out of our normal networks, and then they say, okay, I need a connectivity layer there as well, and then I see how I bring that to the point. And I think it's a similar thing in Europe, especially for direct-to-handset, is like, I might not need it, but, you know, in the moment I have an accident in the woods somewhere, there it would be extremely nice to use it, right? Like a security layer. And that's a little bit the way we look at it we have to make sure, and I really like your statement about saying, make it that at the end, the customer has the benefit of 100% coverage, and anything else doesn't matter, and we make sure how it is. Of course, it's easier when I use operator spectrum to have leverage, way easier than new spectrum, new adoption. We have quite some intensive discussion how we can make it possible, but that's, I mean, it depends on the demand, right? At the end, is if people want it, they want it, so.
No, thank you. So we've got just under 10 minutes left. So I want to use that time to talk about the future, talk about the outlook. One of those, Sunil, is the device landscape, which is we brought this up briefly on the first panel. Scott from AST made some comments on that. How do you see NTN satellite connectivity coming into devices over time? And do you think there will be much variation between the OEM, or do you think we'll broadly see it sort of incorporated for everybody?
So, because, like as we are discussing, clearly there is interest from consumers, even from business side, like, you know, automotive, some of our automotive customers are getting very interested in having satellite connectivity. So broadly, we expect there will be this type of connectivity in multiple types of devices moving forward. And that's something actually we are preparing for. We are working with partners to do that. One of the point, you know, today the way things are evolving is there are multiple things. You know, there is, I mentioned NB-NTN. There is direct to cell using, you know, let's say in some cases terrestrial spectrum. I think what we are trying to you know, in our discussion with partners, we're trying to encourage that one thing we should avoid is having too much fragmentation, where there is, you know, different technology or there is a custom implementation for each of these, and that will actually not help if that's kind of how we progress. So our preference is we kind of converge onto. You know, of course, 3GPP is working on, you know, NR-NTN as one of the technologies. So I think purely from device perspective, I think we prefer that there is some kind of convergence over time for these, like the way these services are offered, at least at the radio access level. That will be very beneficial in the end for the ecosystem to adopt this across multiple types of devices, which is really what all of us are looking for.
Can I say something from
Please.
a previous world where I worked with the device manufacturers? And I think there has to be a lot of communication between the device manufacturer and the MNOs and the satellite providers to understand how you evolve together,
Yeah.
right? And people want optionality, and you need flexibility. And I think having, as we continue to iterate in this industry, to understand where the devices, the consumers will drive demand, but you all will work together to try to meet that and develop standards that are efficient and accessible. So, but that's my other hat. So I'm very sensitive to the device manufacturers as well, and how these technologies work together and develop together.
Yeah. No, that's well said. Mohammed, what do you see? So looking ahead, let's say 12 months. I mean, if we're talking about commercialization timelines here of 2 to 3 years, maybe even 3 to 4, to get continuous service for some of the constellations, what do you see as sort of the key things to get right in the next 12 months to keep the momentum going?
Yeah, well, first, I think in terms of services and the timing, we need to sort of distinguish between the use cases, right? So it's not like everything is later on. There's services that are being offered today, and they can expand. But in terms of making sure that sort of the broadband aspect of things will happen, I think the most important thing to me is the ecosystem coming together. Because there was a good example that you brought up about the automotive. I mean, that's a complex problem to solve. And the ecosystem working together to address all of this is working as one. If I had a choice to say in the next 12 months, what do we do? Is bringing that ecosystem together to really address these problems and not working separately in isolated areas to really accelerate and to meet those kind of timelines for the different applications that we're talking about.
Yeah, well said. Anshay, for you, coming, as I say, from the telco perspective, the operator perspective, looking ahead, what do you think the biggest priorities are, and also what do you think, are there any risks we should be thinking about here?
We would need to make sure it's seamless, and our answer to everything is standardization, of course. It's absolutely crucial for us. We cannot live with priority solutions that is not easy to chip in and so on. So that is the variety is nice, but it has to come together. So and that's for us crucial, that we have actually a healthy ecosystem that we can also then modernize in a way. So we heard something in the previous talk about software layers, right? So we need to come there, and that's what our industry is already, I think, pretty much going into that direction, and we have to find a way to include. And that would be, for me, that customer is no need to feel differences. So that's where we should go.
Seamless experience, yeah. David, what should we expect from Starlink next 12 months? What are the key priorities? What more partnerships, service upgrades? What's on the list?
Yeah. So we'll have correct. We'll have I think we already have a number of partners that are going to be coming online. I think we're expecting some more coming. We're continuing to deploy the constellation, so the service is just going to get better. Right now, it really is just kind of, it's texting. By the end of the year, we're expecting that we're going to be able to have voice, light data. But I think across everything, I think this stuff is moving fast. I think in a few years, I love how many people came to this, but like, I think this is going to be this is going to be boring in a few years. It's, as Julie said, we know what the consumer expectation is, right? Everybody expects this, not just, consumers don't care how they get their service, right? They don't care what's on the back end. They care that their phone works.
Yep.
They care that
But
they
it's
have
cool
it.
to say it came from up there.
Yeah.
Just saying.
Some people like that.
Some people, yeah.
But ultimately, but I think we're not very far away. I mean,
Yeah.
we're working with unmodified phones. It's the phones that are already in your pockets. I think we're just not very far away from just, everyone's going to expect that their phone has this, just like you expect that you have roaming, right? Like, it's not going to be an interesting thing anymore. It's just going to be there.
Yeah.
I think, right now what we're looking at is, because I actually think that this consumer expectations are maybe a little bit ahead of where the services are, because I think consumers are thinking this should be there now.
Yeah.
And I think the way for the wireless operators, the way they're going to differentiate themselves is who can get there first, right? Who can say, I have this now? But I don't think we're very far away from it's going to be that this is just what exists.
Yeah, and the point's well taken. If it's just seamless and it's working, that's almost a sign of success right there, when people expect it and it's there. Julie, we've got 1 minute. You can close us out. Give us your thoughts. Next 12 months, big priorities, risks we should be thinking about.
Yeah.
Super quick.
Absolutely. I think the key is to anticipate, but also to work closely with your regulators as well in whatever markets you're going into. Have a proposed plan, pivot where you need to, but regulators like to help, at least the one I worked for. But I think the next 12 months, we're going to see a lot of really interesting movement, and really excited about it.
Great. Guys, thank you so much for being on stage here. The time just flies by, as always. We could talk for a long time, but we do have 2 more keynotes to go, so we need to get onto those. But you've given us great thoughts, so thank you very much.
Thank you. Thanks so much. Great.
Thank you very much, Mohammed. Thanks, NJ. David, thank you so much. Take care. Julie, thank you very much. It's great. I'll talk to you after, yeah. All right. As I said, we've got 2 more keynotes, first from the European Space Agency, and then Paul Jacobs from Globalstar will close us out. So we are going to move on to the next speaker from the European Space Agency, Laurent Giffard, who's going to talk to us for 10 minutes before the final keynote. So Laurent, thank you very much.
Is it working? Okay, great. So good morning, or almost good afternoon. I'll be relatively quick. I'm working for the European Space Agency. I'm the Director for Connectivity and Secured Communication. And we are working on 5G, 6G. And we worked for the last years on our vision for what will be the future of these non-terrestrial networks and the unification with the terrestrial networks. Just a reminder, we are an agency representing 23 member states. We have 3 associate members, 5 cooperating members, 5,500 workforce, and we have roughly 85 missions currently in space. Our budget for the year 25 is shy of 8 billion. The 5G terrestrial network and the unification with the non-terrestrial network has started with the question of narrowband IoT, the 2-way messaging, emergency services, IoT. All the previous speakers were talking about it. This is available today. But when looking at the future, we're looking at broadband. We're looking at streaming, voice, and this will require an entirely new infrastructure that we need to deploy in LEO, and we need to look at potentially a multi-orbit infrastructure. The ecosystem will benefit from the entire chain. It's not limited to satellite manufacturer. It's not just limited to operators. So on the way to 6G, we're looking at 3D networks. What do we mean by 3D networks? We actually look at multi-orbit. We believe that we need to connect the LEO with the MEO, with the GEO, and provide resilience to the network to deliver quality of 6G. We'll be looking at next generation mobility. This is you with your cell phones, but this is also a huge application around automotive. Standardization, we've worked with the 3GPP. We believe that it is important to embed this non-terrestrial network in the standards from the beginning. And then finally, there's a question of sustainability. Putting so many satellites in space is coming with a liability to make sure that space will be usable for the next generations. And we also need to look at the sustainability of the spectrum. We should allow new business case to materialize. We should not put all the spectrum in the hands of the very, very few. So to get there, we've put together a lab in orbit. We call it LINO. We've made an internal study, 6G Sterling, where we're looking at how to use artificial intelligence to look at the dynamic spectrum monitoring, to look at the end-to-end orchestration, to look at the processing necessary. And we're going to field in orbit a lab. This lab will allow us to test, as we are defining the standards, the definition of the future generation of 6G satellites. AI is going to be all along a key element, and we'll move to dynamic spectrum allocation, sub-terahertz transmissions, and of course the definition of the 6G waveforms. I am based in the UK, and we have established a 5G, 6G hub together with our colleagues from the UK Space Agency, who are just our neighbors. And we're looking at an engineering lab, a demonstration and application lab. Basically, it is a collaborative place where you're invited to come and try your applications, work with us, but also help us showcase why do we need to work with our member states on 5G, 6G. We are continuing, as we explained last year, joint challenges with GSMA. We'll be looking at D2D connectivity, 6G innovation, and our hubs. So far, I would like to end my presentation. I hope you're ready for lunch, but ready to work with us. Thank you very much.
Okay, that is going to bring, and Paul, we got some water here. I'll get you a glass in a minute. I'll get you some water in a minute. That brings us to our final speaker, who is coming to us from Globalstar. It is their CEO, Paul Jacobs. So it's my great pleasure to welcome him to the stage.
Thanks, Tim.
Some water.
So it's great to be back at Mobile World Congress. It's been a little while for me, but always been sort of part of the hot things going on in wireless in the cellular community. Obviously, way back in the day, going to digital cellular, wireless internet revolutions, smartphone revolution, and multimedia on the phone, all the kind of things that got built into the phone. And now this is another new feature that's going into the phone to have the satellite connectivity. But it isn't like we kind of came to this fresh when I came to Globalstar after I left Qualcomm, did a startup on terrestrial cellular technology, which you can go see at our booth. But you know, we've been involved in satellites for a long time. Obviously, you know, it's all started as science fiction in 1945 with Arthur C. Clarke and Sputnik, we all know about in '57. But sort of our involvement dates back, you know, we did video cipher for HBO, so satellite TV back in '86. '88, we did OmniTrax, which was long-haul truck messaging to long-haul truckers. That actually was pre-GPS, included satellite navigation system doing ranging off of multiple satellites to the trucks. obviously GPS then launches in '93, and the story there that's kind of funny is CDMA terminals, or sorry, base stations use GPS to synchronize the base stations, and we were doing one of our first demos, very high profile demo in New York, and a GPS satellite came up over the horizon with its timing wasn't working and threw off the base stations, and my father had to stand up for about an hour and a half and wave his hands. Fortunately, he had been a college professor, so he could do that, but the GPS almost took down CDMA back in the day. Globalstar dates back to '98. That was when the first calls over the satellite system were done. That was a Qualcomm Loral joint venture back then. So I was running the handset business back then at Qualcomm, and helped build some of the first satellite terminals that were used for voice and data services back then. In 2019, I was Richard Branson and Greg Weiler and I sort of kicked off the OneWeb development, and Qualcomm did a bunch of the OneWeb development over time. Then obviously now at Globalstar, sort of September 2024, with our wholesale partner, kind of launched direct to cell. And now we're on to kind of what's next. Like all these capabilities have been built up over time. Now we have this ability to have a big economy built, a big ecosystem built around satellite capabilities, and we're focused at Globalstar on certain aspects of that, because the kind of the way the network was built. And so we start off at the bottom. We have spectrum that's global. We don't have to worry about border issues that were discussed. We don't have to worry about fine-tuning where the beam patterns are. So we got away with the very small constellation of satellites to have global coverage and to launch the service, and we've had that for 30 years now. Obviously, having a LEO constellation, we all know the benefits of that in terms of latency, but it also affects cost, size, and power of the terminals, which then leads to the kinds of applications. It increases the kinds of applications that you can run. The architecture of the system, which was one of the things that attracted me, it's bent pipe. And what that means is that it is a platform by which we can add new innovative technologies pretty much continuously. We've had a bunch of partnerships where people will come to our test bed in Clifton, Texas, and they will just bring their demodulation equipment and their transceivers, and we just hook it up to the system, and in a matter of days, people are up and running with the new technology. And that was certainly one of the things that led to the wholesale business that we have, but it also has led to a government business that we're growing as well, and I think it will lead as we go forward into other opportunities with other partners. We've been selling up until now consumer retail devices. As these capabilities get integrated into the smartphone, it's not so clear where that market will go. Having been involved in integration of a lot of capabilities into smartphones, we see that the standalone device business gets affected, sometimes goes away, but often there's still a niche market for a standalone device that's more tailored, and so we're kind of watching to see how that goes. But obviously, the IoT business is the one that we think there's a lot of growth, and that has been growing for us so far. And that is a lot of different applications, and I'll talk a little bit about that later, but the key there, and it's a lesson I learned at Qualcomm, was when you try and serve a deep vertical, it's really, you can fool yourself by saying, oh, well, I know this vertical and I want to go to this one and this one and this one. I think they're adjacent. But a lot of times the things that you think from outside the vertical as being the critical pain points aren't. Omnitrax, we thought that we were launching Omnitrax to allow dispatchers to shift trucks as they were out to get new loads while they were out on the road. And what actually sold Omnitrax was that it kept the truck from having to go into a truck stop to talk to the dispatcher on the phone. And most accidents happen in a truck stop. And so the insurance went down for the trucking companies, and that's what sold Omnitrax. And we thought, oh, okay, we're going to go to something next to Omnitrax, we're going to service construction equipment. We didn't know what we were doing, that business failed. So having resellers and having partners that really understand the deep verticals are super important, and we have built a group like that, and I would say that's one of the key things for IoT going forward. And then the applications that we're doing now range from things like tracking animals in Mongolia, horses in Mongolia, or sheep in Scandinavia, or kind of what you would think of as sort of low value things, but require something small, low power, obviously very low cost as well. And then up to drones and autonomous vehicles, and looking at various assets that are distributed out in the field. And then that then enables, as we put more compute on the edge, to do things like AI monitoring and alerting over the kind of thin route that we have to transmit back to a central location, then say, okay, now give me more information and so forth. So better monitoring we're able to do. And so what happened actually when I came to Globalstar, we have two-way systems. We had the original duplex from Qualcomm that's actually still running. We have a Spot X, which is a two-way system that looks like a BlackBerry kind of thing. But from IoT standpoint, we were only doing one-way messaging. So 90% of the packets over the network are position locations. The rest of it's some kind of telemetry. And it's only last week that we actually now launched a two-way system for IoT. And so, this is the module that runs it. There's a dev kit, and anybody who's interested, please, come see us. We're definitely looking for partners to grow this. Obviously, it's a business that's been out there, but Globalstar's been able to make a business around one-way IoT, which you would think that was actually turning a bug into the feature, because in the old days, the very first satellites that came up, the transmitter on the satellite, on the S-band transmitter, stopped working. And so they only had a return link. But when I came in, I realized that there's huge benefits to cost, size, power when you don't have a receiver in there. And now with this capability, now we're looking at other incremental applications, and we'll talk a little bit more about that. But obviously the thing that everybody knows and sort of has been talking about Globalstar, and probably the reason why I'm here giving this closing speech, is direct to device market, which, as I said, kicked off. And the commercial services have been up there, and there was a question in the last panel of who has it now, and I suspect most of you in this room have it now, because hundreds of millions of people now have direct-to-cell capability for texting, and I think the price is pretty reasonable for it for those people. And so the question is, what's the business model that goes beyond solving the pain point of safety and security? We get that safety and security, that issue is solved for hundreds of millions of people right now. Now, is it that you want to send pictures back, videos back, voice back? I don't necessarily believe that there's a huge market for Netflix in the mountains, mobile broadband everywhere. I built a business at Qualcomm called MediaFlow, which was during the 3G time. We did a supplementary network that did video, like you had ESPN on and all various networks and cable channels and stuff. And limo drivers in Las Vegas bought it, and pretty much nobody else. And it was a supplemental cost on your cellular bill, and had to get priced at a certain place that was, kind of the $15, $20 range, and it didn't work. And by the way, Globalstar and Iridium went bankrupt years ago trying to provide cellular services outside of cellular coverage, and cellular coverage has only gotten bigger. So I think our way that we look at it is that we know what the business model is for us, which is if you can reduce the replacement cycle of a large mass of devices, that generates a fairly large amount of money, but not so much that you can go build a mega constellation around it. Our constellation is 24 satellites plus an on-orbit spare. We got 17 underway now, and then we have a next generation that's kind of 50 plus satellites, but it's not what I would call a mega. And obviously with OneWeb, we did build a mega for fixed broadband. And in fact, GSMA did a study that said that 72% of people wouldn't pay any more than 5%, and this study was done before the safety and security pain point was already resolved. So the question is, what is the business model that will pay for this? I'm not saying that there isn't, but it isn't a proven business model today. And so we're very focused on what actually makes money, and I would say that's the right thing for the industry to focus on right now. And so now for us, where we're focused a lot is on IoT, as I said, and asset tracking and monitoring is a key area that we're focused on. There's a real business there. I mean, there's a lot of money to be made there. And as AI gets deployed out into the landscape and you care about monitoring remote assets, but you want to do it in a fairly light touch way, not have to ship all the data from the sensors back to a central place to be processed. I think satellite, a relatively thin route satellite connectivity is adequate and actually good. And then with two-way, you can go in and ask, okay, send me more information if it's needed. So, I think the model for IoT is definitely a model that works. The number of us, a number of companies in the industry have been focused on it. I think the D2D market works, but it works, at least the business model we know today, is one around relatively small amounts of data. And I would say that for that, Globalstar's gotten ourselves in a pretty good position because our constellation, which is the key issue for a satellite company, that is being paid for by our wholesale business. And so as we add incremental services on top of that, the return on investment is almost infinite. There's not a lot of CapEx that has to go into it, and that's why we're very open for business to help build an ecosystem on top of this satellite connectivity. We have a lot of spectrum, as I said. We've got a long-term play because just got a 15-year renewal, and we have these new satellites that are going to be launched too. So if you're doing an IoT play, one of the things you care about is that you have a reliable partner that will be there for the long term, and we will be there for the long term. And it's the same spectrum, so it's single SKU around the world, and we've been doing this for a while. So that's, I think, the way that you want to win from space. It's the way that we're focused on it, and we're very much, as I have been in previous roles, focused on building an ecosystem here, and definitely think there's a lot of opportunity in non-terrestrial networks. I just think that we need to focus as an industry on what is actually the economically viable things to do and build the ecosystem around that. And with that, I will let you guys all go to lunch, but thanks very much for giving me the time to talk to you.
Paul, that's a great way to close it out and great thoughts. So that, as Paul said, that does bring us to the end of the summit. It was packed throughout. I hope you guys got a lot of good use out of that, and we really appreciate you coming. We will be hosting the slides from my opening presentation on our website. You can get the research. If you do have any questions, some of the speakers may be around afterwards to answer those, but we hope to see you back next year. I'm sure we'll have just as much to talk about, so thank you again.